In previous videos, we've looked at how to determine the domain and range if we're given either a set of ordered pairs or a graph. But in this case, we're going to look at how to determine the domain or the implied domain if we're given an equation. Generally speaking, I always encourage my students to assume the domain is all reals unless these two things occur. If there's a radical present, or if there is a variable in the denominator of a fraction. We're going to look at an example of each of those. So again, when given an equation, assume the domain is all reals unless one of these two things occurs. So let's look at a radical. For example, if you are given the function f of x equals 5x minus the square root of 3 minus x, it has this radical I was speaking of. From our previous studies on radicals, we know that we cannot take the square root of a negative number. So if the function has a radical, you take whatever's under the radical, and because we know it can't be negative, we restrict it and say that it has to be greater than or equal to 0. We are not worried about any other parts of the equation. And then we solve for x. So here I will subtract 3, and I get negative x is greater than or equal to negative 3. Dividing by negative 1, and then flipping my inequality, I get x is less than or equal to 3. When I put this on a number line, notice 3 is included, so it's a closed dot, and x has to be less than or equal to 3. So my domain is going to be an interval from negative infinity to 3. I can then check this. So for example, if I plug in and try to evaluate the function at 5, 5 is not in the domain. 5 is out here, and so the function should not have a value. When I plug 5 in, I have 5 times 5 minus the square root of 3 minus 5, which gives me 25 minus the square root of negative 2. And we know we can't take the square root of a negative number, and as suspected, the equation does not have a value at 5. The second scenario to look for when determining implied domain is there a variable in the denominator of a fraction. So for example, if we see something like this, we have a variable in the denominator of a fraction, and we know denominators can never be 0. In order to determine the implied domain, then, all we're worried about is the denominator, and that denominator can't be 0. Again, we solve for x, so I add 1 to both sides, and I get x squared is equal to 1. I take the square root of both sides, and don't forget that plus or minus, so x cannot be plus or minus 1. When I put that on a number line, at 1, it's going to be open. At negative 1, it's going to be open, but it's going to include everything in between. So my interval will actually have 3 pieces. It will go from negative infinity to negative 1, which encompasses this piece. Or it will go from negative 1 to 1, which encompasses this piece. Or it will go from 1 to infinity, which encompasses this piece. And this is the domain.